The topic is about capacitor, LC and CLC section filter, which can be used after a rectifier to make the converted AC to DC signal to reduce little more ripple component. Capacitor filter is an inexpensive filter for lighter loads. It can be connected directly across the load resistance itself. We know capacitor allows the AC signal and blocks DC signal. That's the reason we have placed the capacitor in parallel, whereas we keep the inductor filter in series to the circuit. So the capacitor to short the ripple to the ground and leave the DC component appear across the load resistance. So during the positive half signal, the capacitor charges to the peak of the transformer secondary voltage Vm, maintain this value and then drops to 0. So capacitor will discharge through RL slowly till the transformer secondary voltage again increases to value greater than the capacitor's load voltage which is the load voltage. So the diode conducts for a period which depends on the capacitor voltage. So higher the capacitance, rectification will be more, but we can't exceed the specified current in the specification sheets. So the ripple voltage can be assumed as a triangular waveform. Here this period from where charging happens here and discharging happens here. So this discharging period is cutout point from the top to here, and the charging period is called as cut-in point, and this period is T by 2 from the peak point to the discharging time is T by 2, and this time is charging time is T1. So the charge it has acquired is VR peak to peak XC, and charge it has lost is IDC into T2. So charge acquired is equal to charge lost, and then VR peak to peak is IDC by 2FC. VRMS is VR peak to peak by 2 root 3, and VRMS is VDC by 4 root 3 FCRL. So ripple factor becomes, when F equal to 50 Hz, capacitor value is in microfarad and RL is in ohm, ripple factor is 2890 by CRL. Next, the LC filter. Ripple factor, we include a inductance in series to the circuit and capacitance in parallel to the circuit. Ripple factor is proportional to the load resistance in the inductor filter and inversely proportional to RL in the capacitance filter. So to make the output ripple independent of RL, we go for this LC filter. So here V0 is 2Vm by pi minus 4Vm by 3 pi cos 2 omega t, and VDC is 2Vm by pi. IRMS is root 2 by 3 VDC by XL, and VRMS is root 2 by 3 VDC XC by XL. Ripple factor is root 2 by 3 1 by 4 omega square CL, and for frequency 50 Hz, ripple factor is 1.194 by LC. CLC or pi section filter, we have two capacitances, one inductor and the load resistance. So capacitor followed by an inductor. Capacitor filter followed by a LC filter is the CLC or pi section filter. So it provides smooth output and is characterized by a high peak diode current and poor regulation. So here we have the ripple value for 60 Hz 3300 divided by C1, C2, L1, L2. So this is about the capacitor, LC and CLC filter. Thank you.